Okay, I'm just going to go through a matrices question 5 from the revision sheet. We've got a matrix A, minus 1 half minus root 3 over 2, root 3 over 2 minus 1 half. And part A asks you to describe fully the single geometrical transformation U represented by the matrix A. So, the way you can do this is consider the basis vectors, which would be 1, 0 and 0, 1. If you apply the transformation, which is U or matrix A, these basis vectors, well, 1, 0 goes to this vector, which is minus a half root 3 over 2. Which is there. And the other vector goes to this, which is minus root 3 over 2, minus a half, minus root 3 over 2, minus a half, which goes down there. So to me this looks like a rotation, and if you think about how many degrees, well, that there, if that's theta, that's opposite, that's adjacent, tan theta, opposite would be a half, adjacent's root 3 over 2, 1 over root 3, which is 30 degrees, so that angle there is 30 degrees. So for this looks like a anti-clockwise rotation about 0, 0 by 30 degrees. Sorry, not 30 degrees, by 90 plus 30, which is 120 degrees. Okay, so that's part A done. Part B, the transformation V represented by the 2 by 2 matrix B is a reflection in the line y is equal to negative x right down the matrix B. So again, if you consider the basis, which would be 1, 0 and 0, 1. Reflection in the line y is equal to negative x, so that would be this line. Where would that basis end up? The red vector would go there, which is 0, negative 1. The green vector would go there, which is minus 1, 0. And matrix B would be the image of red and the image of green, like so. Part C, given that U followed by V is the transformation T, which is represented by the matrix C, find the matrix C. So C is equal to U followed by V. So you have to do U first, and U was, which one was U? U was the first one, so A first, then B, so it's equal to BA. Bit of matrix multiplication. That's going to go to 0 times that, minus 1 times that, so minus root 3 over 2, 0 times that, minus 1 times that, so that's a half, minus 1 times that, which is plus a half, and minus 1 times that, which is root 3 over 2. And that would be matrix C. Then part D, show that there's a real number k for which the point 1k is invariant under T. Okay. Alright, let's try and do this. So invariant would be, if you did txy, an invariant point would be mapped to itself. So we want t1k go into 1k, and matrix T is the thing we just worked out, which was minus root 3 over 2, a half, root 3 over 2, times by 1k needs to go to 1k. Right, if you did the matrix multiplication on the left hand side, you'd get minus root 3 over 2 plus a half k, and a half times, plus root 3 over 2k, that needs to equal 1k. You've got two equations with one unknown, so in other words, minus root 3 over 2 plus a half k needs to equal 1, and a half plus root 3 over 2k needs to equal k. If you solve the first one, you get k is equal to, so if you add root 3 over 2 and then times by 2, that would be 2 plus root 3. And then if you solved this one, it should give you exactly the same answer. Let's check it on the calculator. Okay, so just do one step. Half equals k 1 minus root 3 over 2. Divide by that, so we've got 0.5 divided by 1 subtract root 3 over 2, 2 plus root 3. So there's the one real value. And that would be it. That's the 10 marks.